Suppose I have to factor a polynomial like this one. Now, one thing I do notice is that this is a square and 49 is a square and y is also a square. So, and there's a subtraction between them, so that's the difference of two squares factoring pattern. So that will factor. I'm just going to take the square root of each of those terms, so x and 7y and x and 7y. And then in order to get rid of the middle term, remember we have to have a plus and a minus, because when I FOIL this, we get the first and we get the last. That's not the problem. It's the outside is negative 7xy and the inside is positive 7xy, which cancels out, so we don't have a middle term. Okay? So again, I mean, I noticed that there were squares. I know it was subtraction, so it's that difference of two squares pattern. If I had been given, let's see. How about x squared, y squared, minus, let's see, let's try. I don't want to do this exact problem for you. How about 25? No, 25 is what's there. How about 100? All right, so I'm noticing both of these are squares. So how can I apply this idea where I took the square root of this and the square root of this, and then put a plus and minus sign between them? So you see what's going on here. I hope that helps without me doing much more for that. This next problem, you factored out a 2 correctly. So then we've got this sum of two cubes, because x is a cube and 27 is a cube. So you gotta have on a piece of paper or memorize those two factoring patterns. And I'll show you the patterns again, and then we'll also I'll do an example or two for you. So the patterns are. So here's those two patterns who were in the lesson. The trick is what's A and what's B. So for this problem here, I see that x is a cubed and 64 is 4 cubed, right? So really the way I can think about this is that x is being cubed and 4 is being cubed, and this tells me that this is the A and this is the B, and there's this plus, so as an addition, so this is the sum of two cubes. All I have to do is take those values and drop them into the A and B in the factoring patterns. So that factors to, so x plus 4 times x squared minus 4 times x plus 16. Okay, if they had told me something a little more tricky, like let's see, how about 125 x cubed plus, well, let's use 64 again. Okay, so I've got to ask myself, well, I think these are cubes. Is something being cubed? Well, 5 cubed is 125. So 5x is my A, and 4 again is my B. And then because this is the sum, I just got to drop it in that same pattern. So 5x plus 4 is the A plus B up here, right? A plus B, just like I did here, A plus B. And then I'm going to multiply that by A squared. So 5x times 5x is 25x squared. Then it's minus A times B, so 4 times 5x is 20x, and it's negative. And then plus the b squared, which will be 16. Okay, and you can do the same thing with the difference of two cubes. The only thing that happens is the negative switches here. And you need this in order to be able to drop out those middle terms. If I were to think about this as x plus 4 times x plus 4 times x plus 4, well, that's gonna FOIL out. I'm gonna have a whole bunch of middle terms. I mean, just on this part here, that's gonna give me x squared plus 8x plus 16, and then if I distribute that x plus 4 through, well, that's gonna be, I'll have x cubes, but I'll have some middle terms too. Okay, so that's why you gotta, unfortunately, we just gotta memorize these patterns to factor. So for this last one, it looks like you were looking for some help. it looks like you use that AC method, which is fantastic. It certainly is a way to work. When it comes to this part here where you divide by the 21, you have to simplify that fraction first. Otherwise, you're going to get much, because if I were to FOIL this, I would get 21 times 21, whatever that is, x squared, not the 21. So reduce those fractions first. That's what I'll tell you. If you want, I can do another problem just like this right now for you. All right, so what I've got covered up here is the answer. I created the answer and then made the problem. So once I'm done, we can go back and double check. So here's the quadratic that I got to try to factor. So I didn't know, so I multiplied 24 by 14 and got 336. And then I had to come up with the factors of 336 that would add, give me 37. I know I'm going to add them because they're two positives. So I made a factor tree because I didn't know the factors of 336. And I listed all the prime factors. This is why your 7th grade math teacher, at least in my school, they learned this in 7th grade, taught you about prime factors. So then I said, well, let's see, I've got 2 to the 4 through 16, because there's 4 2's, and then this 3 and the 7. And then I noticed, wow, this is lucky, that because 16 plus 21 is 37. So it looks like the factors that I want for 336 are 16 and 21. So x plus 16 and x plus 21, and that's what you did fine up here. The part where you forgot to do is, okay, so now I'm going to divide by 24, you did that, but now you have to reduce this fraction, you have to simplify this fraction. So that becomes x plus, let's say I'm going to divide both those by 8, so 2 over 3, and that becomes x plus, and I can divide both of those by 3, and get 7 over 8. And then, of course, then I got to do that multiplication trick to clear that denominator. So 3x plus 2 times 8x plus 7 is, I think, what the answer is, and I could FOIL it to check. But if I go back up and delete, let's see if it'll let me delete my arrows here. So we can see the moment of truth here. And x plus 7, x plus 7, 2, 3x plus 2, 3x plus 2. So that's the process. So the last step that you want to remember is you're going to divide, you got to simplify that fraction, okay, before you do this trick. Otherwise you'll get too large of answers. Okay, hope this helps you finish answering these questions.